Good morning, dear students. My name is Ferhan Mazher, and today is 5th January 2022. And right now, I am with the 11th Cambridge class. And today, the subject we are studying is Physics 5054. It's Cambridge O levels physics. And today, we have set our hearts to solve a theory paper. We have selected October November 2017 2 paper. This paper belongs from the zone 2. We also call it variant 2. In this session, in this video, we will be solving the section B of this paper. The section A of this paper I have already solved, and we have made a video on it, and it is already uploaded in my YouTube channel. So you can watch that. Today, in this session, we are going to work on the section B. Section B starts from the question number 9. It comprises of question 9, 10, and 11. So let's start today's work. Hopefully you will enjoy. So October, November 2017, Physics 505422, section B of this paper. Question number 9 is showing up on your screen. He says figure 9.1 shows an astronaut in space near to a space station in the orbit above the Earth. So here you can see an astronaut, and that astronaut is tied with this space station with the help of this rope, and he's outside the space station. So the total, let me reduce the size so you can see this remarkable photo. The total mass of the astronaut and all his equipment is 160 kg. The astronaut is initially at rest relative to the space station, but he is then pulled towards, the astronaut initially at rest relative to the space station, but he is then pulled towards the space station by the rope. His acceleration towards the space station is 0.35 meter per second square for 1.2 seconds. Calculate the resultant force that causes a mass of 160 kg to accelerate at 0.35 meter per second square. So if you want to calculate the resultant force, we can use the Newton's second law of motion, which says F is equals to ma, where F is the resultant force, m is the mass of the body, and a is the acceleration of the body. So I will apply the Newton's second law. We know the mass, that should be in kg. We know the acceleration, that's 0.3. Very easily we can find out. So let me show you the acceleration. So on your screen, F is equals to ma, 160, mass is 160 kg, and the a is 0.35 meter per second square. Just multiply them, you get 56 Newton. So the resultant force is 56 Newton. So that was the question number 9, and it's A and first part. The second part is the speed at which the astronaut is traveling after 1.2 seconds. Okay, so after 1.2 seconds, let me show you the whole thing. It's a 2 marks numerical. The astronaut is initially at rest. The initial velocity is 0. The acceleration is 0.35 meter per second square. And what will be his final velocity after 1.2 seconds? Now, you have studied the definition of the acceleration, which is A is equals to V minus U, the whole thing divided by T. From there, we can make the V, the final velocity, the subject of the formula. Let me show you. Very easy. I had a famous equation. So, okay, so the initial velocity is 0. That's represented with the U. Final velocity V is question. Acceleration is 0.35 meter per second square. T is 1.2 seconds. V equals to U plus AT. That's the definition of the acceleration. A is V minus U divided by T. So V is equals to U plus AT. U is 0. A is 0.35. T is 1.20. When you multiply them, you get the final velocity 0.42 meter per second. I hope you understand this. Okay, so let's go to the next numerical. Next part. It was a 2 marks numerical. The resultant force on the astronaut is constant for 1.2 seconds, but then it decreases to zero instantly as the rope becomes slack. On the figure 9.2, sketch the speed time graph for the astronaut for the first 3 seconds of his motion. Okay, now you see for the 1.2 seconds, the resultant force is constant. So the astronaut will be accelerating at a constant rate. And it's a speed time graph. And in the speed time graph, when the acceleration is uniform, the graph will be an inclined straight line whose gradient will be constant. And when immediately the resultant force becomes zero, the acceleration will also become zero. So that means that the body will start moving with the constant speed. And on the speed time graph, the constant speed is shown by a horizontal line. Let me show you. It's a 2-mark question. Let me show you this. Okay. So up to approximately 1.2 will be here till 1.2 seconds. The astronaut is accelerating at a uniform rate. And here the acceleration becomes zero because the resultant force becomes zero. So now the body will start moving. The speed time graph will become a horizontal line because the acceleration will be zero. The body will be moving at a constant speed. Hopefully you understand. Okay, so let's move to the next part. He says, describe how the distance moved by the astronaut during the first 3 seconds may be found using the speed time graph. Okay, a very famous question, very famous question. If you want to find out the distance moved by the astronaut, and you have the speed time graph, you find the area under the speed time graph. So if you find the area under the speed time graph, means this area, you will be able to find out the distance traveled. Okay, so here is my answer. Area under the speed time graph, in the first 3 seconds will be equals to the distance traveled. So this is how you will answer that. Okay, so let's move to the next part, and the next part is okay. He says that the space station is traveling at a constant speed in a circular orbit around the Earth, as shown in the figure 9.3. So the space station is basically moving around the Earth like this. A force acts on the space station to keep it in this orbit. On the figure 9.3, draw an arrow to show the direction of this force. Because this satellite is moving in a circular path, so all the time it is being subject to a force which we call centripetal force, and the direction of that centripetal force is always towards the center of that circle in which that body is moving. So I will draw an arrow here which will be directed towards the center of that circle. So it's a 1-mark question. Let me show you my here we go. I have. So on your screen, you can see that, you can see with the red line, I have shown that arrow, which is showing the direction of the centripetal force, and it is towards the center of that circle. Hopefully you understand. Okay, so the question number question number 9C first, and the second part is explain what causes this force. You see, the satellite is basically revolving around the Earth, and the centripetal force is towards the center of this Earth. So this is the centripetal force, and the centripetal force basically is being provided here. The Earth and the satellite, they both are masses, so they have attraction. Their attraction with each other is known as the gravitational force of attraction. So this centripetal force is basically provided by the gravitational attraction between the Earth and that satellite. And this is the law of gravitation, Newton's law of gravitation, that any two objects in the universe who has mass, they always attract each other. That is known as the gravitational attraction. So that centripetal force is being provided by the gravitational attraction between the satellite and the Earth. Okay, let me show you my written answer. The force of gravitational attraction between Earth and the space station provides the centripetal force. Hopefully you understand. Okay, so the next part. Then he says, it's a very simple question. That was a 2-mark question. Now, the second part, second part is state what is meant by the velocity of an object. You know, velocity means the rate of change of displacement, change in the displacement divided by time. So that's the definition of the velocity. So let me show you my definition. I've written that definition. Okay. So the velocity is a 2 marks definition. The rate of change of displacement is called velocity. Okay, so let's move to the next part, and it says state and explain what happens during the orbit to the velocity of the space station. You see, because the satellite is moving in a circular orbit, so at every moment its direction has to be changed. So you know the velocity is a vector quantity, and the velocity has magnitude and direction as well. And in the question, the statement of the question, he said that it is moving at a constant speed. Although the magnitude of the velocity is not changing, but the direction of the velocity has to change, because whenever a body moves in a circular orbit, it has to change its direction. So the direction of the velocity is changing. That's why we can, with full confidence, we can say the velocity of the space station is changing. Its magnitude is not changing, but its direction is changing, and velocity is magnitude plus the direction, because velocity is a vector quantity. So that's why I can say that the velocity is changing. It's a 1-mark question. Then before I go to my answer, let's do this, finish this. The kinetic energy of the space station. You see, the kinetic energy is a scalar quantity. The formula for the kinetic energy is 1/2 mv squared. So here in the formula 1/2 mv squared, the mass of the space station is not changing. The magnitude, the v is the magnitude of the speed. The magnitude of the speed is not changing. It means the kinetic energy is 1/2 mv squared. The mass is not changing. The speed is not changing. The direction of the velocity is changing. But here in this formula, because the kinetic energy is a scalar quantity, the speed is not changing. The magnitude, basically, the velocity's magnitude is not changing. So it means that the kinetic energy will not change. So let's it's the last part of the question number 9. So let's look at my answers. Okay, the first part, velocity changes. Its magnitude is constant, but its direction is changing. And the second part is kinetic energy of the space station remains constant because m is constant and magnitude of the velocity is also constant. Here the velocity is not constant, but the magnitude of the velocity is constant. Because the kinetic energy is a scalar quantity, so it's not changing. Hopefully you understand this point. Okay, so let's have a look at the marking scheme. Here we go. So my dear students, on your screen, so on your screen, question number 9 of the October number 2017 2-2 paper. Question number 9 is marking scheme is showing up. I have already checked my answers with the marking scheme, but for you it is very important to always check your answers, compare your answers with the marking scheme. Okay, so what you can do, you can pause the video and take your time, have a good look at this, study, read each and every sentence of this marking scheme. I hope you have checked your answers. So now let's go back to the next question. The next question coming up on your screen. Question number 10. A boiler containing water is plugged into a 230-volt main supply. The heater in the boiler is operating at full power. The power used by the heater is 2.8 kilowatt. Calculate the current in the heater. The power is given 2.8 kilowatt and the voltage is given 230 volt. And we can very easily find the amount of current. The power is equals to IV, a very famous formula. But there is a problem. The power here in that, the power which you use in that formula, P is equals to IV, the power should be in the watts. So 2.8 kilowatt means you multiply it with 1000, so it will be in the watts. The power must be in the watts. And then you can apply the formula. Let me show you my work. Okay. So here we go. So the power is 2.8 kilowatts. I will convert it into the watts and I will multiply it with 1000. It will become 2800 watts. The voltage is 230 volt. The formula for the electric power is P equals to IV. I will be equals to P divided by V. I equals to 2800 divided by 230. And that will be 12.17 ampere, just like 12.2 amperes. Okay, so the current will be 12.17 ampere. So let's move to the next part. He says the wiring in the cable from the socket and in the boiler remains safe and does not overheat, provided that the current is less than 20 ampere. Suggest a suitable fuse rating for the circuit. Okay, this wiring can bear up to 20 amperes, but don't get confused with this number. Actually, the heater is taking only 12.17 ampere current. So what should be the rating of the fuse? The rating of the fuse should be more than 12.17 ampere. It can be 13 ampere, it can be 16 ampere, but it cannot be more than 20 ampere. So write any number which is more than 12.17 ampere and less than 20 amperes. Because if you provide 20 ampere current, the wiring will overheat. So the rating of the fuse, for example, I say it should be 16 ampere. So here you can see I have shown that question number 10A, second part, 16 ampere. Okay. Now the B part, question number 10B part. The specific heat capacity of the water is 4200 joules per kg per degree centigrade. The heater is used to increase the temperature of 6.3 kg of water. In a certain time, the temperature of the water increases from 23 degree to 49 degree. Calculate the change in the internal energy of the water. Okay, so because here change in the temperature is involved, and I always tell you that remember that formula, that when the change in the temperature is involved, the formula for the heat is mc delta theta. Heat is equals to mc delta theta, where m is the mass, c is the specific heat capacity, and delta theta means the change in the temperature. The specific heat capacity of the water is given 4200 joules per kg per degree centigrade. The mass of the water is given, that's 6.3 kg of water. And the change in temperature, the temperature changed from 23 to 49. So very easily I can calculate how much is the heat involved. That's the 2 marks question. And let me show you my answer. So heat is equals to mc delta theta. So m is 6.3 kg, c is 4200 joules per kg per degree centigrade, and the change in the temperature is 49 minus 23, that's 26. So just enter these values in your calculator and you will get 6.9 expo 5 joules. So the heat will be 6.9 expo 5 joules. Hopefully you understand this numerical. It's a very, very famous question. Okay, then the question is, the heater supplies thermal energy to the water at a constant rate. It takes more time for the temperature of the water to increase from 49 to 75 degrees centigrade than from 23 to 49 degrees centigrade. In both cases, the increase in the temperature is the same. So just why it takes more time for the temperature to increase from 49 to 75 degrees centigrade. You see, he says that the heater is still providing the same power, operating at the same power, and the change in the temperature when the water temperature changed from 23 to 49 is 27. I think 27, yeah, or maybe 26. And sorry, 26, yeah. From 23 to 49, it's 26. And when the same water, when its temperature was 49 and it changed to 75, the change in temperature is still the 20, 26. But now the heater takes longer time. Why? That's the question. So just why it takes more time for the temperature to increase from 49 degrees centigrade to 75 degrees centigrade? That's the question. The reason is very simple. You see, when the water's temperature was changing from 23 degree to 49 degree, the water's temperature relative to the condition when the water temperature was changing from 49 to 75, now the water is more hot. Its temperature relative to the surrounding is higher. The more the temperature difference between the surrounding and the water, the greater will be the rate of evaporation. There will be a greater rate of loss of thermal energy to the surrounding. You know, the temperature, the water, when its temperature will be higher as compared to the surrounding, more the difference of temperature between the surrounding and the water, the larger will be the rate of evaporation, and that's a loss of heat because water going into the air by the evaporation, taking away the heat. So why it takes longer time when you try to change the temperature of water from 49 to 75? Because at this high temperature, the water's rate of evaporation has increased. And it means that the heat loss to the surrounding, the rate of the heat loss to the surrounding has also increased. This is a 1 mark question, but it's very technical answer. So I hope you will be able to write its answer. Let me show you my answer. I've tried to write its answer. But water is at higher temperature, so rate of evaporation will be faster as compared to the rate of evaporation when the water was from 23 to 49. So heat loss to the surrounding will be at a larger rate. Will also have a larger rate when water changes temperature from 49 to 75. I hope you understand. It's a 1 mark question. Okay, so let's move to the next part. Figure 10.1. Figure 10.1 shows the heater at the bottom of the water in the boiler. Explain how thermal energy is a 3-mark question. Explain how thermal energy is transferred from the heater throughout the water. You see what will happen. Remember, it's a very, very, very famous question, frequently asked question, where you have to actually describe how the convection takes place in the water. So the water which is near this heater, they will absorb the thermal energy. The water molecules will move away from each other. The volume of the water here will become larger. The water will become less dense. This less dense water will rise upward. The cold water here on the top, it will be more dense, and that dense water will sink downward. So from here, the hot water, which is less dense, is going upward here from the top. The cold water, which is more dense, will be sinking down. And that will create here, that will set here convection currents. So by the help of those convection currents, the heat will be distributed throughout the body of the water. It's a 3-mark question. Let me show you my answer. Water near heater absorbs thermal energy. Molecules of water move away from each other. Water becomes less dense. Less dense water rises upward. Cold water, which is more dense, sinks. Thus, convection currents are set in water. By convection currents, heat is distributed throughout the water in the water. Hopefully, you understand, and you will be able to write an answer which can score 3 out of 3 marks for you. Okay, so let's move to the next part. The next part is also of the 3 marks. He says the part of the boiler that holds the water is made from steel. Describe in terms of particles how thermal energy passes through the steel. So this is basically, you have to describe how the conduction takes place in a metal. So whenever you want to describe the conduction taking place in the metal, there are 2 ways to do this. Because the conduction takes place by two methods in a metal. One is by the vibration of the molecules, the energy is transferred. So what will happen? The molecules which are at the hot end of the steel, they will absorb the thermal energy, and they will be in their fixed position, but their vibration, its amplitude will increase. So now they are vibrating vigorously, and their amplitude has increased. So they will collide obviously with their neighbors, and they will make their neighbor particles vibrate vigorously, and they will make their neighbors vibrate vigorously. In this way, through the vigorous vibrations being transferred to their neighbors, the energy will be transferred from the hot end to the cold end. So that is one part of that explanation. In the second part, the steel is a metal, it's a conductor, it has free electrons in it. So what will happen? The free electron has a very important thing. They can flow in the steel. They can move from one corner of the steel to the other corner. They are not like the molecules of the steel, which are stationary. They are fixed on the one position. They can move around. So the free electrons, which are at the hot end, they will absorb the thermal energy, and they will flow, and they will go to the cold end, and they will collide with the atoms, the molecules there, and they will make them vibrate vigorously. So by the flow of the electrons from the hot end to the cold end, the energy will be transferred. That's called conduction. This process has a special name. We call it free electron diffusion. Let me show you my answer. It's a 3-mark question. Very important, very famous, frequently asked question. So molecules which are in contact with the hot water absorb thermal energy. They start vibrating vigorously. We're talking about the molecules of the steel. Their amplitude of vibration increases, so they make their neighboring molecules to vibrate vigorously. So by the vibration of the molecules, heat is transferred. Steel also have free electrons which can flow in steel. Free electrons absorb heat and flow to cold end of the steel. There they make molecules of the steel vibrate vigorously by colliding with them. This is called free electron diffusion. This whole process is how the conduction takes place in the steel, and the heat travels from the hot end to the cold end. Hopefully you understand. The third part is state and explain in terms of particles. What happens to the density of the steel as its temperature increases? You see, when the temperature increases, the vibration of the steel particles, they become vigorous. The amplitude of their vibration increases. So the distance, the space between the molecules will also increase. So the steel will expand. Now the volume of the steel will increase because the molecules have moved away from each other, so the steel will expand. So due to this expansion, the volume will become larger, but the mass will not change. The density is mass divided by volume. So now the mass is still the same, and the volume has increased because the density is mass divided by volume. So the density will decrease. Okay, so let me show you my written answer. It's a 2-mark question. Okay. When temperature rises, steel will expand. Its volume will become larger. Its mass will not change. Density of the steel will decrease because the density is mass divided by volume. Mass still the same, volume increased, so the density will decrease. Hopefully you understand. So we are done with the question number 10. And let me see from here. Okay, now question 11 is okay, so let's have a look at the marking scheme for the question number 10. Okay, so my dear students, the marking scheme for the question number 10 is showing up on your screen. You can pause the video and you can take your time and check my answers, your teacher's answer, your book's answers. It is very important to check the answers. So that was question number 10. Okay, especially check the answers of these three-mark questions. This question number 10, C first, 10, C second, 10, C third. Please have a good look on them. pause the video, give time to this marking scheme. It's very, very important. Okay, so let's move. Yeah, now we are on the. Let's move to the next question. The next question is on your screen, and that's question number 11. He says, the metals in the list below have many different uses: aluminum, copper, iron, silver, steel. State which metal from the list is used for a compass needle. Compass needle is basically a magnet. So steel makes permanent magnets. So here I will write steel. Magnetic screening. For magnetic screening, we always used soft iron. So iron will be written here. The core of the transformer. The core of the transformer is also made of soft iron. So here you will write soft iron. It's a 2-mark question. Let me show you my answer. So you can see steel, iron, iron. Hopefully you understand. He said, describe one use of a transformer. You see, the transformer is basically used to increase the voltage, and the transformers which increase the voltage, we call them step-up transformers. Transformer is also used to decrease the voltage. The transformers which do this thing, that they are known as step-down transformers. For example, in the power station, when the electricity is generated, and from there, when you send the electricity to transmission lines, before that we use a step-up transformer, and we increase the voltage. We make the voltage very, very high. And when the electricity reaches your town and the real consumer, there we put another transformer, which is a step-down transformer, and that decreases the voltage. So the transformer's basic function is to increase the voltage or decrease the voltage. So you have to, let me show you my answer. Transformer is used to step up or step down voltage. At power station, voltage is stepped up with help of a step-up transformer before sending current into the transmission lines. Okay. So an AC generator supplies an input voltage of 220 volt to a transformer. In the space below, sketch a graph of the output voltage against time for an AC generator. AC generator producing alternating current. So its voltage will be becoming positive, negative, positive, negative. And this will be happening after a certain interval of time. Periodically, this will be happening. So here you can see I have shown that graph. And on the x-axis, we have represented time in seconds. On the y-axis, we have represented the voltage. You can see I have represented the positive voltage, negative voltage, both. And after a certain time, the voltage is changing, okay, it's periodically. So this is called a sinusoidal wave. This wave is called sinusoidal wave, okay? So this is what they are asking you. This represents the alternating voltage. Hopefully you understand. The transformer has 1,700 turns on the primary coil and 85 turns on the secondary coil. Calculate the output voltage of the transformer. The input voltage of the transformer is 220 volt, and the number of turns in the primary are given, the number of turns on the secondary are given. So they want the voltage, the secondary voltage. Very simple. Let me show you how we have done this. Okay, so Vs by Vp is equals to Ns by Np, and Vs is question, the voltage in the secondary, and Vp is 220 volt. And number of turns in the secondary are 85. The number of turns in the primary are 1700. So Vs will be equals to 85 multiplied 220 divided by 1700, and you will get 11. So the voltage in the secondary coil will be 11. The output voltage will be 11 volt. Hopefully you understand this numerical. It's also very famous. So question number 11 and C part, figure 11.1 shows a magnet next to one end of a solenoid. The terminals of the solenoid are connected to a very sensitive ammeter. The magnet is moved to the right at a constant speed and a reading is observed on the ammeter. Explain why there is a current in the ammeter. It's a 3-mark question. So you see, when this south pole is moving towards right, it is coming near this coil. Its magnetic flux, its magnetic lines, they are passing through this solenoid. And when this south pole is approaching, that magnetic lines, that magnetic flux which is passing through this solenoid, that will change. So when the magnetic flux passing through a coil changes, automatically, according to the Faraday's law, EMF is induced in that solenoid, in that coil. So the ammeter will show a reading, ammeter will show a deflection, which will show that the current is being produced in this coil. So let me show you my answer. I've written this answer. It's a 3-mark question, very important. Magnetic flux of magnet is passing through the solenoid. As magnet moves towards right, magnetic flux passing through the solenoid changes. Thus, EMF is induced in the solenoid and ammeter will show some reading. It will show some deflection. It's a 3-mark question, very important. Hopefully you understand. The next part is also of 2 marks. It is of 2 marks. Explain how the current in the ammeter opposes the changes producing it. You see, this is Lenz's law, and the current which is induced in that solenoid, it will make that solenoid left and a south pole, because the south pole of the magnet is approaching that left end of the solenoid. So the current which will be induced in the solenoid, it will make that solenoid an electromagnet, and that electromagnet's south pole will be on the left side of the solenoid. So it can oppose the south pole of that permanent magnet which is approaching that. In the simple word, you can say the current which will be induced in the solenoid, its direction will be such that it will try to oppose the cause which is producing that current. Let me show you my answer. Direction of the current induced in solenoid will be such that it will try to oppose the cause inducing it. So the electromagnet formed on solenoid will have its south pole on its left end to oppose the approaching south pole of the magnet. Hopefully you understand this is Lenz's law on which this question is based. You must have studied 2 laws. One is the Faraday's law and the other one is Lenz's law. Faraday's law is about the magnitude of the induced EMF, and the Lenz's law is about the direction of the induced EMF. Hopefully you understand. Now we have on this second part but this is C and its second part. Yeah, it says the magnet stops when the south pole reaches the middle of the solenoid. The reading on the ammeter is observed when the magnet is moved to the left at a constant speed that is less than its speed in the C first part. State 2 ways in which the reading on the ammeter differs from the reading observed in the C first part as the magnet moves to the left. So there are 2 things they are saying, and now the magnet is moved towards the left. Before, the magnet was moving to the right. And now it is moving at a constant speed that is less than the speed which was in the C first part. So the current which will be induced, that will be in the opposite direction, plus that the amount of that, the EMF of that current will be less. The amount of current will be also less. So the ammeter, it will have 2 differences now. The reading on the ammeter, it will show less reading, the less deflection of the pointer of the ammeter, and this time the current will have a different direction. The ammeter's pointer will be deflected in the opposite direction. whatever the direction it deflected in the C first part. Now it will deflect in an opposite direction. So let me show you my answer. I have also written the answer. So let's have a look at my answer. Smaller deflection, deflection will be opposite. That's my answer. So my dear students, we are done with this paper, and let's have a look at the first of all the answer of this question number 11. Okay, so now on your screen, the question number 11, its marking scheme is showing up. You can pause the video and take your time, read this marking scheme. I have already checked my work, but you can stop the video, check your answers, compare them with the marking scheme. Check my answers with the marking scheme. Whoever gives an answer on physics, check its answer with the marking scheme. It's a must. It's a must. This is that habit which will polish you. It will polish you to excel in the physics. And I'm talking about the CAIE exam. So we are done with this paper today, my dear students. We have done October, November 2017 Physics 505422 paper. In this video, we have done the section B of this paper, and the section A of this paper we have already done, and it is already uploaded in my YouTube channel. If you find this video helpful to you, if you find this video interesting, and if you think that I am explaining the thing and you are able to understand it, please share the link of this video onto your Facebook accounts, into your Instagram accounts, onto your Twitter accounts. Share the link of this video with your friends, with your class fellows, with your teachers, with your senior students, with your junior students. This might be helpful to them. Thank you very much. It's a great blessing for me to teach you online. Thank you very much. Have a good day. God bless you all.